All right, so 6.1 translations. You learned a little bit yesterday about the different types of transformations. Translations is actually the easiest one to deal with, and it can be thought of as a slide. When you slide all points of a figure the same distance in the same direction. It's literally taking something and just sliding it to the left, sliding it to the right, sliding it up, or sliding it down. Okay. The original figure is called the pre-image, and that's a word you're going to need to know simply because it's going to be in instructions, and you're going to need to know what it's referring to. And then the translated figure, the one after you have moved it, is called the image. Once again, you're going to need to know that word. You can use an array called a vector to show the direction and distance the original figure is moving. We can describe translations by using vectors or by using coordinates. We will focus on coordinate notation for this lesson, but there is a visual of what a vector looks like, and it can also describe the transformation. The whole idea of vectors you'll get more into when you move on in math. Right now we're going to focus on coordinate notation. Okay, so to translate using a vector, hang on just a minute. To translate using a vector, a segment from the pre-image, remember the pre-image is the original one, to its corresponding image must have the same length as the vector and be parallel to all the other vectors, as direction is important. In this example, we have our pre-image, which is triangle ABC. It will be translated along vector V, and the image will be notated with this A and then an apostrophe, B and then apostrophe, and C apostrophe. That is known as A prime, B prime, and C prime. So anytime you see the letters like that, you know that's the pre-image. Anytime you see A prime, B prime, C prime, or X prime, Y prime, Z prime, doesn't matter what letters they use, but with those little apostrophes, those are the image. So image and pre-image. I-M-A-G-E. Okay? So if I look at this vector, and I look, see it has an arrow, so I need to start at the other end. It looks like it's going 5 spaces to the left, 1, 2, 3, 4, 5, and 2 down. So what that's telling me is I need to take each one of those points and move them 1, 2, 3, 4, 5, and 2 down. So if I take point A and I move it 5 to the left and 2 down, that's where A prime is going to be. Pre-image, image. If I take point B, the pre-image, and I move it 5 to the left, 1, 2, 3, 4, 5, and 2 down, that's where B prime is going to be. If I take point C, pre-image, and I move it 5 to the left and 2 down, guess what? That's where C prime is. And when I connect those dots, or those points, I have the transformation, or the translation, that figure has been slid that direction. Okay? Another way to indicate a transformation is to use this notation, this capital T, and it says T, and then in little writing here it says 4, 1. That notation says, well, first off, you notice this is like an X value and a Y value. Well, an X value tells you to go left or right, and a Y value tells you to go up or down. So this notation says go 4, positive 4. You're going to add 4 to the X values, and you're going to add 1 to the y values, meaning you're sliding the figure 4 units right and 1 unit up. Okay, so that's another notation that you could see. We will use a coordinate plane, or coordinate, coordinate. It's hard to talk and write at the same time. Coordinate notation to describe a translation. So this is what coordinate notation looks like, and this is the one I really want to spend some time with. Okay, this is what you need to be familiar with. Coordinate notation. This part of it you should be familiar with. You should know what an XY point is. And then from there, you notice they take x plus h and y plus k. Well, just like here, x plus h tells you how far to the left or right the figure is going to translate. The k tells you how far to the up, I'm going to say take off the 2, how far, and the up or down the figure is translated. So again, x tells us left to right, y tells us up and down. Okay, so rules for translations. This is going to be key to you. Okay, this part's going to be very important. If you are translating to the right, it's going to look, sorry, my son ran in there, as translating h units to the right means I take my x value and I am going to add h to it. So xy changes to x plus h, comma, y. If I am translating h units to the left, what do you think I would do? Well, think about your x-axis. To the left would be negative numbers, so I would have a minus h right there. K tells us our up and down movement. So if I'm translating it k units up, I'm not going to change the x value at all. I'm going to add k to the y value. Your x value doesn't change when you go up and down. It only changes the y value. If I'm translating k units down, that means I would have minus k with the y value there. Now, that probably seems confusing, but I promise it's going to get clearer. Okay, so just bear with me. So let's turn this paper over and see where we're going from here. So, example 1, given the translation where the blank, I, J, K, so they have I, J, and K, and then if you notice, this is in a different color, and it also says I prime, J prime, K prime. So that means I, J, K is the pre-image. And I is at the point 0, 1, 2, 3, 4. I'm going to say J, not B. J is at 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then K is at 5, 2. Then what are we going to call triangle I prime, J prime, K prime? That is the image. And it has coordinates negative 3, 0, 2, 1, and 2, negative 2. How has it moved? Identify the translation, meaning here's your XY. I need to figure out how it has moved as far as an H and a K. So to do that, you just want to pick one point, because if nothing has changed, each point is going to move the exact same way to get to its new location. So pick whichever point you want to and focus on how that one moved. So if I look at just point I, and I want to see how did I move to I prime. Well, it went that way and then that way. And if I wanted to go down and over, I could do that also. I just like to move left to right first, because left to right gives me my X value. So how did it move? It moved 3 units to the left. Knowing our x-axis, Moving to the left means we are subtracting 3, right? 3 units to the left. I can also refer back here. Moving to the left on the other side means it's going to be a minus. And then it moved down, which means my k value that goes with y is also going to be a minus. And how far is that? 1, 2, 3, 4. And as soon as you identify that, you should be able to count that for every other point. So if I move j 3 units to the left and 4 units down, I should end up at j prime, and I do. Same thing with k. If I move that 3 units to the left and then 1, 2, 3, 4 units down, I end up at k prime. Okay, so this is my answer to this problem. There's 2 figures there, and this is what it's asking you to come up with. Okay? All right. Example 2. Find the coordinates of the vertices of each figure after the given transformation. So, I'm going to do this one in a different color. I need to translate this 5 units right and 3 units up. So I'm going to take each point and go 5 units right and 3 units up. So if I take H, and I go 1, 2, 3, 4, 5 units right, and 1, 2, 3 units up, that new point is H prime. And I'm going to list the coordinates of H prime is 0, 2. That's the image of H. Now I'm going to move point I, 5 units right and 3 units up. 1, 2, 3, 4, 5. 1, 2, 3. And if I look down here, H and I are directly next to each other. H prime and I prime should also be directly next to each other, and it does work out that way. So I prime coordinates would be 2, 2. Okay, and remember when you're writing ordered pairs, you always need parentheses around them, otherwise they are wrong. Okay, let's do G. If I move 5 units to the right, 1, 2, 3, 4, 5, and 1 unit, I'm sorry, not 1 unit up, 3 units up, I find where G prime should be. So G prime is 1, 0. And then finally J, 1, 2, 3, 4, 5 to the right, and 3 up gives me J prime. And it looks like the coordinates of J prime are 1, 2, 3, negative 1. Okay, and I should connect the dots so that they do, connect the points I should say, so they do match up with the figure. You can see the figure has just slid. Now, let's look for a minute. If I was asked to do what I did up here to this one, I would say X comma Y, arrow, and then I would say parentheses, oops, X, and what did I do? I moved 5 units to the right. That means I have a plus 5, comma, Y, 3 units up would be plus 3. And if you actually looked at the original coordinates, if I looked at the coordinates of H, let me move this so you can see it. H was originally 1, 2, 3, 4, 5, negative 5, negative 1. And if you look at that negative 5, if you add 5 to that, guess what? You get the X value of H prime. And if you take that Y value and you add 3 to it, you get the Y value of H prime. Same thing with I. If you take the original coordinates, add 5 to the X and 3 to the Y, you will get the image coordinates. Okay, so be aware of that. All right, example 3. Here is my translation. They're giving it to me in that coordinate notation. I need to find the coordinates of the vertices. So I have triangle STU. So I'm going to be looking for S prime, T prime, and U prime. Now, let's talk for a minute. What does this mean? This means I am going to move which direction with my X. That means if it's X minus, I'm moving to the left. So I'm moving left 8. And Y plus 4 means I am moving up 4. So I can do this two different ways. I could either take each point, move them 1, 2, 3, 4, 5, 6, 7, 8, and then up 4, and call that one S prime. I could do the same thing here. 1, 2, 3, 4, 5, 6, 7, 8, and then up 4 right there, that's T prime. And then you do the same thing, 1, 2, 3, 4, 5, 6, 7, 8, and then up 1, 2, 3, 4, and that would be U prime, and I could come up with those coordinates. But I want to show you something really quick. If I wrote down these original coordinates, S, T, and U, the coordinates of the pre-image. S is the point 3, comma, -4. T is the point 4, -1. And U is the point 1, 2, 3, 4, 5, -4. If I subtract 8 from 3, so in other words, 3 minus 8, I get -5, right? And if I take -4 and I add 4, I get 0. Let's verify. Is that where S prime ended up? Is it at -1, 2, 3, 4, 5, 0? It is. Okay, so I can do it by graphing it, or I can do it by dealing with the coordinates. If I do the same thing to T, if I take 4 and I subtract 8, that gives me -4. And then if I take -1 and I add 4, that gives me +3. Let's verify. 1, 2, 3, 4, 1, 2, 3, that is where T prime ended up. And then finally U, if I take 5 and I subtract 8, I get -3. And if I take -4 and I add 4, I get 0. Let's verify. 1, 2, 3 in the negative direction, and then 0 in the y direction. So that's what my answer looks like there. Okay, didn't buck my answer over here. Okay, all right, happy studying.